Yo, calc students, what is going down? So in the last video, I talked about integration using long division. If you missed that, go back and check out that video. It'll really help you in solving integrals using long division. In this video, we're going to switch gears. We're going to be a little bit on that same topic, but we're going to talk about integration using completing the square. Before we get started, if you want to see more videos like this to help you prepare for the AP exam, subscribe, turn on notifications, and leave a comment if there's any other topics that you would love to see me do so that you can get a 5 on that AP Calc AB or AP Calc BC exam. Without further ado, let's go ahead and jump into the example problem for the video. Come on, let's find the example problem, then pause the video! Alright, so before we get started on completing the square, there are a couple things I want you to make sure that you know, and I want you to make sure that you review. A couple of them are these key antiderivatives right here. You're going to need to be able to know these in order to do completing the square. Because the whole point of completing the square is we're going to rearrange the integral to look like one of these two antiderivatives so we can make that antiderivative appear. And most likely that's going to use some u substitution, but we're going to use completing the square to manipulate it into being able to be u substituted. Also, make sure you know how to complete the square before going into doing this. I think that the hardest part for students is not the calculus. It's the completing the square and having to dig that out of your Algebra 2 mind. And honestly, that was probably, in my mind, one of the hardest things you did in Algebra 2. So make sure you've got that fresh in your brain. And then I think you got this concept down, honestly. So without further ado, let's get into the practice problem. Alright, now before solving any integral, your mind needs to think about, okay, can I use u substitution, integration by parts, integration by partial fractions, anything like that? Is there any way I can simplify this integral without having to rely on this? Now, obviously you know that we're going to have to use completing the square, but I just want you to remember to try and use other ways before resorting to completing the square and long division. That should be your last resort. There should be another way for you to solve the integral. Let's go over the completing the square part though. Notice, we don't have square root sign in the denominator. What does he think that means? That means we're going to be putting it into an inverse trig form. If you saw the square root, you'd probably think, oh yeah, we're probably putting it into inverse sine form. But we're putting it into inverse tangent form because there is no square root. So let's manipulate this and use completing the square to see if we can maybe simplify this even further. So let's take a look. Remember, in order to complete the square, what do we have to do? Well, we have to do b over 2 squared. What's b? b is 4. 4 divided by 2. I'm just going to do it off the side, but I'm going to delete it in the end. 4 divided by 2, that's 2. Square it, that's going to come out to be 4. So we need to get something. Really what we need to do is I'm going to take this and I'm going to move it. I'm going to move it over because really we're going to add 4 in here and cut it off right there. Now we've got our perfect trinomial. That's what we're going for. But now, if I add 4, I'd have to add 4 on the other side. This is an expression. So how can I get the adding 4 to go away? It's pretty simple. You're just going to end up subtracting 4 right here. So obviously, that's what the math is going to simplify out to. I'm going to simplify this one more step by factoring out this part into the perfect square trinomial, factoring it backwards, and then maybe doing some more simplifying. So let me do that real quick. So there we go. I got it simplified a little bit more. Now you guys, remember, let's look back at our inverse tangent. For our inverse tangent, we got to get a 1 somewhere there. Well, we're kind of there. We've got our x squared. Can we please just scroll down? We've got our x squared. Obviously, that's where we're going to use our u substitution, guys. So we've got our x squared, but we don't have our 1. We've got this 4 right here that's kind of lying in the way. And so the only way to get rid of that 4 is if we factor out a factor of 4. Now that sounds really complicated, but guys, it's not something maybe people would think of right away. But think about it. If we factor out a factor of 4, obviously we're going to be left with a 1. But what is this going to come out to be? Well, think about it. It's just going to be this value divided by 4. So I'm going to get x plus 2 squared. Oh, that was really ugly. X plus 2 squared over 4. That's what that's going to look like. That's what it's going to look like. So I'm going to give myself some more screen real estate here. And we're going to keep going. We are going to keep going. So next I'm going to switch back to white. I don't know why I started using white and yellow, but just follow with me. I'm going to take out that factor of 4, which is really a factor of 1/4. I'm going to pull that constant out in front of the integral, and I keep leaving off my dx's. You really don't do as I say, not as I do. Please don't leave out your dx's. That's just going to make you lose points. Don't follow my lead there. I'm going to pull out that constant of 1/4, and that's going to get me a 1 in the numerator, and I'm going to get a 1 plus. Now I'm going to rewrite this a little bit. Now 4 is the perfect square of 2, right? Because 2 squared is 4. 4 is the perfect square of 2. So I'm going to rewrite this as 2 squared. So that's what this looks like. Now look guys. When you have a squared divided by a squared, remember, let's use our exponent properties. Let's pull that exponent out. So that's actually going to be 1/4. I forgot my dx again. I reminded you guys, and I still forgot. So now I'll be left with 1 over 1 plus, and we're going to pull out that whole squared, x plus 2 over 2 squared. All right, now let's see here. Okay, all right, let's make our u go ahead and be x plus 2 over 2. Now if we simplify this, that means u is going to be 1/2 x plus 1. The derivative of that, du, is going to be 1/2 dx. I don't see a 1/2 anywhere here, so we're going to have to do a little bit of rewriting, re-engineering. So let's put a 1/2 right there, just because. But if I put a 1/2 out here, I'm going to have to multiply by the reciprocal outside the integral. So I'm going to multiply this by 2. That's going to be 2/4 or 1/2. So we're going to get rid of this. We're going to put a 1/2 out front. And now, u substitution, this is going to become u. Then we're going to get a 1 up top because it's going to be, instead of a dx, it's going to be a du. And we're going to get 1/2 times the inverse tangent, right? Because we know it's inverse tangent. We were trying to engineer it into the inverse tangent. So we know it has to be inverse tangent. And obviously that u was x plus 2 over 2. And don't forget, it's an indefinite integral. Gotta add that plus c. That is your answer, folks. That is how to do completing the square with integrals. You guys, don't freak out so much about that whole completing the square with integrals. You guys, my guess is you're not gonna have to do it on the free response section of the AP exam. And worst comes to worst, maybe 2-3 questions of the entire multiple choice is going to be asked on this. It's not going to be a huge topic on the AP exam if College Board even decides to put it on there at all. So it might be there. You might want to be prepared for it. And if you've got the time to study it, do it. But if you're 2 days before the exam and you're starting your studying, or you're a week before the exam and you're starting your studying, do not start your studying with completing the square and long division, because it's just not going to probably be on the exam all that often. You're going to lose maybe 2 points tops for not knowing that concept. And 2 points in the grand scheme of the AP exam, that means nothing. Because remember, you're not doing this to get 100%. You're doing this to pass. And passing is basically failing. It's like basically a 50% F on this test. So just keep that in mind. 2 points is going to mean absolutely nothing for your 5. That being said, hopefully you guys get it, and that when those 2 questions are all around, you'll be good to go. So thank you guys so much for watching, and I'll see you guys in the next calculus video. Peace out!